Welcome again. Today we will be focusing on the formation of fronts or boundaries. So remember we introduced the characteristics of air masses and said air masses are modified by the surfaces which they pass, and their later properties will also depend on the nature of the surface they pass over, in addition to their source region characteristics. So if an air mass or if air masses with different characteristics collide, they do not mix, but a front develops, which is a boundary line separating the two air masses. So the area along which two air masses meet is called a frontal surface. There are different types of fronts, which include a warm front, a cold front, occlude front, and a stationary front. Now, you should be able to draw these fronts when you are asked to describe what a warm front looks like, what a cold front looks like, what a stationary front looks like. So let's look into the cold front. A cold front is a front in which cold air is replacing warm air at the surface. A cold front is shown on a symbiotic chart with a sharp triangle. So you have a line and we have sharp triangles on the line. So when cold air moves towards warm air, a cold front is formed. The warm air rises over the cold air, forming a steep wedge than a warm front. It is formed when cold air moves into regions of warm air. A cold front usually brings heavy rainfall of short duration accompanied by thunderstorms. Then we move to the warm front. It is formed when warm and cold air masses meet. The air masses do not mix but form a front. Warm air rises over dense cold air. Upon reaching condensation, nimbostratus clouds are formed, resulting in light showers of long duration. It is a front in which warm air replaces cooler air at the surface. A warm front is associated with saturation, cloud formation, and precipitation. Now let's look at the stationary front. The stationary front is a front that does not move or barely moves. They develop when polar air masses are modified greatly and they lose their character. It also results from the stalling of either a warm or cold front, and it can remain stationary for several days. Now, occlude front. An occlude front is a combination of the cold and warm front. It occurs when the cold front catches up with the warm front. The cold air forces the warm air up. It is formed when a cold front moves faster than a warm front and it overtakes it. The weather ahead of an occlude front brings cloud formation and some form of precipitation. The weather behind an occlude front is dark. It is associated with cumulonimbus clouds, which brings cold weather and continuous rainfall. So in our next lesson, we will move on to the intertropical convergence zone. So now, when we are dealing with formation of boundaries, you want to understand what is happening. So this is an explanation where we are saying that two air masses are meeting and they have different characteristics, and when they meet, they do not mix, which means one of the air masses, which is slightly dense, is forced to rise. Remember when we talked about convection and convergence. So now one of the air masses is forced to rise. But now here we are talking about the convergence of two different air masses with two different characteristics. And we said on a cold front, we are having the cold air replacing warm air at the surface. And then when the cold air moves towards the warm air, a cold front is formed. Then the warm air rises over the cold air, forming a steeper wedge than a warm front. It is formed when cold air moves into the regions of warm air. Then we talk on the warm front, where it is formed when warm and cold air masses meet, and then the air masses are not going to mix. The warm air is then forced to rise over the dense cold air. And then upon reaching condensation, nimbostratus clouds are formed, which result in light showers of long duration. And on a cold front, we said we have heavy rainfall of short duration accompanied by thunderstorms. Then the stationary front, it is not movement. There is no movement. So they develop when polar air masses are modified greatly and they lose their character. Then last we talked about the occlude front, which brings cloud formation and some form of precipitation. So we have two, right? A combination of the cold and the warm front. The cold front and the warm front. And then the weather behind the occlude front is dark, right? It is associated with cumulonimbus cloud, which brings cold weather and continuous rainfall. And then the weather ahead of the occlude front brings cloud formation and some form of precipitation. So occlude front, we are having a combination of cold and the warm front. Then stationary front, they develop when polar air masses are modified greatly. Then a warm front, this is when warm and cold air masses meet. And then a cold front, this is when cold air is replacing warm air at the surface. Follow us on our Facebook page, Surface Scholars Academy, and also on YouTube to listen to more and have more of these lessons. For more information or for your resource person, you can actually contact us on +263 782 108 484. Thank you.